Hello there. Are you struggling in finding solutions in your software problems? Oh, that's bad. But if you watch this video until the very end, I'll assure you that you will learn the four main phases that are clearly identifiable in the process of solving problems. But before anything else, my name is Engineer Dictado at your service. So let's start. Hi guys, I'm back. Do you want to know what are the software problems that we might encounter? And now you know the problems. Let's proceed. So here's the scenario. Problem number 1. Your client Mark asks you to improve his account and make it more secure than before. You know that there is someone who wants to hack his account because of constant notification he receives through his email. So based on Mark, he is experiencing a constant notification he receives through his email and fear of losing his account. To solve this problem, we engineers know the four main phases that are clearly identifiable in the process of solving problems. So here is a scenario on how Engineer Dictado solved the problem of Mark. La 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 la. Kring kring. Oh, notification from my Gmail. Looks like another customer is failing. From Gmail. Your account is continuously lagging in another devices. Please secure your account. Wait, what? Oh no! Someone is trying to hack my account. I need to call my friend Engineer Dictado for immediate action and to resolve my problem ASAP. Hello? Good afternoon, my friend. Good afternoon, Sir Mark. How can I help you? Someone is trying to hack my account. Please help me. Okay, sir, but before anything else, let me video call you and share your screen for me to understand well your main problem. Also, give me your account, sir, just to check if anything has changed in your account. Okay, engineer. Thank you so much. Okay, sir. Okay, sir. Based on my analysis from your account, there is no changes nor abusive posts and threat messages. But recently, you logged in your account in the device named PC19. To know that, sir, go to Settings, then click your Privacy, then look for the Security and Logged In, and then you will see where you're logged in. Eventually, you accidentally input your password in the user text field. When you do that, that will automatically save from the text field. I'll share my screen, sir, for better understanding. Okay, sir, as you can see, there are some various of usernames that are already saved here in the text field. And then I will give you an example. For example at gmail.com, and you accidentally type your password in this text field, just like that, and you logged in. Yan. Then if you type again the username you input, as you can see, your recent input has been saved, just like that, sir.
Okay, sir. Thank you. Very informative. What should I do, sir?
There's nothing to worry about, sir. I have handled many cases related to your problem, so I can say that I can manage your problem, sir. Also, your hacker is not pro enough to invade in your account.
Oh, That's good.
Yes, sir. But I have doubt that your account will still vulnerable to hacking.
Oh no, sir. Please make my account invulnerable to all
Okay,
problems.
sir, leave this to me. But I can't assure you that your account will be invulnerable for lifetime. Because as time passes by, our technology is improving and many hacker is still learning. So my advice to you is first keep changing your account's password every month. Next, input lower and upper cases letter, number, and other symbols. Note that make your password not less than 8 characters and make sure that your password is not related to you. Got it, sir? Last is activate the verification code. For every time you log in your account, there is a verification code that will send to you through your email. And that will make your account resistant to unexpected logs in. You're always welcome, sir. Just contact me if anything happens. I'll be there for you. And that is one way on how engineers solve a software problems. Next, you will learn the techniques in solving software problems. Let's start. Is the understanding the problem. It may seem obvious that in order to be able to solve a problem, we have to first understand it. Next, under it is the understand the statement of the problem. This is a sanity check to make sure that the software specifications are correctly stated. Next is the understand the goals. Here we question the goals and outputs of the project to ensure that they are sound, but also to reveal the explicit all the problems that we may have to face while undertaking the project. Next is understand the data. Here we question the inputs of the software and all the data provided upfront or are expected to be available for the software to be properly functional. Next is the understand the conditions. Here we question all the assumptions, constraints, and conditions specified for the software, such as validation, business rules, quality, usability, security, and performance tasks, etc. Last is a build a model. Geometric problems are easier to understand and reason upon if we can visualize them in a drawing or a 3D model. The second one is the devising the plan. Once the problem has been properly understood, we enter the core phase of the problem solving planning. This is the phase where we evaluate and devise the different solution strategies. Under it is the analogy. Analogy is a strategy of using the knowledge from previously solved problems that are closely related to the one at hand, or at least share some commonalities. Next is the decomposing and recombining. To solve a complex problem, we may try to decompose it into other problems that are both easier to solve and that can be used as a stepping stones as to reach our original goals. Next is the variation of the problem. When a problem seems too complex to be solved, we instead solve an auxiliary problem derived from the original through different types of alterations. The purpose of alterations is to obtain a different problem, simpler or more familiar, in the hope that its solution may help us with the original problem, or at least give us some useful insights. Next is auxiliary elements. When we do not know how to solve a certain problem, we can always try to solve a related one. Adding auxiliary elements can help bridging the solution of the related problem to the solutions of more difficult problems. Next is removing elements. When we are stuck on the difficult obstacle that is slowing down our progress, we may pretend to make the obstacle disappearing with an imaginary magic wand. Next is the generalization. The more ambitious plan may have more chances of success. This idea is also known as the inventor's paradox. With generalization, instead of solving a specific problem, we solve a broader and more generic one whose solution includes the solution of the specific problem that we need to solve. Next is specialization. It is the opposite of generalization. This mental operation can be very useful for explanatory purposes. Last is working backwards. When we have no clue on how to reach a solution from the given data or conditions, we can try examining the last point that we have reached in the analysis and retrace our step backward until we discover a path between the data and the goal. The third one is carrying out the plan. It is a work of synthesis, rigorous, and scrupulous execution. Under of it is the top-down execution. A top-down order is very relevant when digging into the details of the solution. Before to tackle the minor aspects, we need first to work out the major ones to make sure that they are sound. Next is the importance and challenge. Some tasks are more important than others in the big picture. Some tasks also present a higher challenge than others. If a step next is breaking dependencies. Steps may naturally depend upon each other. Each software component usually relies on other to achieve its goals. Next is the consolidating the efforts. Complex software solutions can be carried out by many developers and many teams, eventually spread out in the different geographical locations. Next is bottom-up testing. Testing is usually a bottom-up process that starts by writing unit tests and then moves up to functional tests for modules, integration tests, all the way up to the whole solution. Next one is the pedantry and master. Dependent software engineers relies conscientiously and indiscriminately on a limited, well-known set of tools, patterns, and practices that are proven to be successful in the most cases. Last one is the retrospection. The final phase of problem solving is looking back at our completed solutions to expand its potential and consolidate our knowledge. Under it is the cleanup. To sharpen our solution, we need to remove duplication, redundancy, and code verbosity. Simplicity and clarity are also important goals of the cleanup phase. Next one is the maintenance and scalability. Good software solutions need to be able to cope with future changes. Therefore, we need to verify the reasonably expected maintenance confirms to the initial expectations. Next is reuse. The main objective of the modular software is to be able to reuse as much as possible its component in different contexts. Lastly, compare and improve. Authoring a solution gives us a point of view on the problem that we solve. Writing an informal document can be exceptionally useful to record a high-level description of the strategies adopted, the strong points, the identified limitations, and any interesting idea or suggestion that emerged during the retrospection.
So that's all, guys. Thank you for watching, and I hope you learned a lot. And that's all. Thank you. Peace out.